Hello everyone, I'm Dr. An. Today, let's talk about text augmentation. In general, the more data we have, the better machine learning model performance we can achieve. However, it is often very labor and resource intensive to annotate a large amount of training data. Therefore, proper data augmentation is useful to boost up our model performance. As an example, in the field of natural language processing, if we have a sentence, I love drinking coffee, well, there are multiple ways to say the same sentence. For example, I like drinking coffee, or I like coffee, or coffee is my favorite beverage. The NLpaug module implements a number of high-performance text augmentation algorithms that may significantly boost performance of NLP models. And this module introduced some cool text augmentation functions in the NLpaug module. So let's dive into it. First, you want to install and import various modules. And you may first want to install the most recent version of GenSim module, which is widely used in natural language processing, because the Colab version of GenSim seems to be a little bit outdated. In order to avoid receiving error messages when running the NLpaug module, you are encouraged to install the most recent version of the GenSim module following the command here. And after that, you can check your GenSim version. So it should be 4.2 or higher in order for the models in the NLpaug module to run smoothly. Here, I remind you, you need to restart the runtime in order to import the most recent version of GenSim module. After that, you also want to install the transformers from Hugging Face in order to use some of their base models, for example, BERT model or Roberta model. After that, you can import the transformers into your session. Also, for some of the back translation tasks that we are going to do, you need special tokenizers. You can install the tokenizers this way and then import the tokenizer into your session. And finally, you want to install the NLpaug module. After that, you can import certain functions and methods from that module. Here, we want to download some modules that can be used for the NLpaug module. Here, we downloaded one version of word-to-text model, a version of fast test model, and a version of the Globe model. You are also feel free to download other models as listed here. And then you can cross-compare the differences and performances of those alternative models. For example, if you deal with Twitter data, and then probably the global.twitter.27b, standing for 27 billion, parameter could be a better choice than the glove.6b. And it's going to take a little while for you to download the model. And then let's do this experiment. First, let's define some text that we want to do text augmentation on. So here, I provide just a single string of text. Is daily coffee consumption good for our health? I guess it is reasonable to believe so, but it may also depend on how much you drink. And here, I illustrate and handpicked a few of the many options that you can utilize the NLpaug module. The first option I want to highlight is to substitute or insert word randomly using the word embedding similarity. Underlying, they are using the similarity word embeddings in one of the models, you can use the word-to-vec model or the glove model or the fast test model to replace one or more word from the text in order to form a new string containing the augmented text. So let's test it out. First, let's initialize the augmenter with the model word-to-vec. We can use the function word embeds aug to do so. You need to provide the model type as well as the model path. And since you've already downloaded the model in your Colab in the Google Drive, so therefore it can be accessed directly. And in the action, you can specify whether you want to substitute a word with a new word or you want to insert a new word. And here I choose substitute. And then after you initialize the augmentation function, you'll be able to use it on the text that we specified earlier. And now let's compare the original test versus the augmented test. Again, the original test is daily coffee consumption good for our health? I guess it is reasonable to believe so, but it may also depend on how much you drink. The augmented text is in the form of a list. It says, is daily coffee and processed grains good depriving our adrenal palates? Had, I guess, is resolved around particularized suspicion to believe, but it may also adversely affect on how much you drink. So the augmentation added some words that seems pretty random. And really depending on your goal, sometimes we do appreciate those randomness in word substitution because considering many texts from social media have a lot of misspellings and abbreviations and other non-alphabetical symbols. So some kind of randomness in those generated augmented tests would be useful to improve the robustness of model training. But other times, we may not need that much randomness, and we do want to have coherent, although a little bit different expression or rephrasing the original text. And now let's try to initialize the augmenter with the model fast text. And again, you need to specify the model type as fast text and also the model path that you've already downloaded the model into your temporary Colab path. And also you can select action substitute. Again, let's take a look of the augmented text. Is nearly daily coffee consumption good for our health? I surmise it is equitable to believe so, but it might actually depending on you how much you drink. It seems a little more coherent compared to the previous augmented text generated by the word-to-vec, but still some randomness there. And now let's try out the third model, the glove model. And specifically, we use the glove 6,300D TXT. There are other models that you've downloaded as well. Try to try them out. And the augmented text is daily coffee good for our health? I guess it can reasonable continue belief. So go it if you depend on how some anybody ate. So again, it seems to be relatively coherent, but with some grammatical mistakes and confusing part as well. And now let's try out the second option. We can substitute or insert word by contextual word embeddings using some of the pre-trained large language models called the base models provided by Hugging Face. For example, you can choose between bird, distilled bird, which is a more succinct version of bird. You can also choose Roberta, which is built on bird, and XLNet, which is another large language model. And here we use the function contextual word embedding aug, and we specify the model. The model won't have to be pre-downloaded because remember, you've imported the transformer. So therefore, as long as you specify the name of the models, it can be downloaded directly from the Hugging Face hub. And now let's take a look of the generated text. The augmented text is daily coffee as good for that waitress? I guess it appears reasonable to use her, but it may certainly depend on how much you serve. This probably doesn't make tons of sense, considering actually that bird was trained on large corpus. So prediction partially based on the contents that were used to train the bird model. So this seems to be a bit of distant from the original meaning of the text. And now let's move on to option 3. We can substitute or insert word by synonym. And here we are going to use the built-in synonym dictionary in the nlpaug module. It's called WordNet. And we just need to use the synonym-aug function and set WordNet as the argument for the source of the augmentation. And now let's take a look of the augmented text. Is casual coffee consumption skillful for our health? I guess it is reasonable to think so. Simply information technology may also calculate on how much you drink. So this is quite interesting because obviously it replaces good with skillful because they tend to be synonym. And also mistakenly because previously in the original text we have it, but it is it if capitalized. I guess because the WordNet use encased sentences and words to train, so therefore it just equivalent the IT as information technology and use that to substitute it. So this definitely is a bit off from the original meaning of the text. And optionally, you can also set the maximum number of words to replace with synonym using the argument augmax. So here I set augmax equal 3, meaning that I only want to replace at most 3 words in the original text with the synonyms. So here is the augmented text. It seems pretty much the same as the previous one, although here it uses the word reckon instead of to replace the depend. And the very last option, option 4, is to substitute or insert word using back translation. So this is a very interesting approach and one of my favorite approaches to do text augmentation. And in a nutshell, back translation means that you first translate the original text into a different language, for example, in German or in Chinese or in Italian or in Spanish. And then you use another language model to translate back into English. So because in the translation, some of the words might be changed, so that adds to some variability to the original data set, original text. And but while it is not guaranteed, sometimes the translation, if you translate one sentence to another language and then translate back, the translated text would be exactly the same as the original text, which in that case you does not gain anything by doing the back translation. On the other hand, well, in the majority of the time, especially when the sentence have some complex structure, usually you will see that the back translation changes the original text a little bit. So let's test this out. You can experiment with different models. Here, we just use the Facebook language model that translate English to German, and then it then translate them back to English. Okay, you can try different models to see whether you get interesting or different results. And I'll use the function back translation arg to do so. And here, let's take a look at the results. The augmented text is daily coffee consumption good for our health? I think it is reasonable to believe so, but it can also depend on how much you drink. So if you compare this augmented text, back translated text to the original one, I think the only change is that previously in the original text it uses may, but now it uses can instead. So the change is minimal, and sometimes if the sentence is very simple, structure and grammatically wise, then you may possibly get exactly the same sentence back. You can always try different models to see whether you get some interesting and high quality text augmentation. So this is the first session of the 3 sessions on the text augmentation. In the next 2 sessions, we will talk about how we can utilize text augmentation to in the process of natural language processing model training and evaluate whether and to what extent text augmentation may improve modeling results and modeling performance. Thank you so much for your attention, and I'll see you next time.